Hello there, Mr. Sutton bringing you a lesson on midsegments. We'll be using properties of midsegments to find missing lengths and angles. And for our real-life application, we'll find lengths of hard-to-reach parts of a roof truss. For your warm-up, we've got three parts. First, show that triangle ADE and triangle ABC are similar. Then, find the length of this side BC over here. And finally, figure out if DE and BC are parallel. All right, let's see how it went doing that first part. So to show these are similar, remember we have three different ways of proving triangles are similar. What information do we have? Well, we have all three sides of the little triangle, but not the big one. So side, side, side can't be used. How about angle, angle? We have one angle that these two triangles share, so we at least have that much, but we don't know anything about any of the other angles, so we can't use angle, angle. So that leaves side, angle, side. Let's look at the different sides here. 4 over 5 versus 8 over 10. Are those proportional? So we could write 4 over 8 equals 5 over 10, and those both reduce to 1/2. So those are indeed proportional, and we can show these are similar by side, angle, side. Now that we've shown they're similar, we can use this to help find the length of BC. We can say, for example, 3 over the corresponding side BC equals 4 over the corresponding side of 8. Cross-multiplying, we have 4 times BC equals 24. Dividing by 4, we have BC equals 6. So this is twice the length of 3. And finally, are DE and BC parallel? Well, we know that angles ADE and ABC are going to be the same. Because the triangles are similar, that tells us that these corresponding angles are the same. But now these are also corresponding angles in terms of if we have two lines with a transversal. Since the corresponding angles here are congruent, that means that these lines have to be parallel. And hey, actually, as it turns out, we have just proved the whole midsegment theorem, which we're now going to officially state. Let's first define the term midsegment. A midsegment connects the midpoints of two sides. And we know these are the midpoints because these two segments on either side of it are the same. Now, the midsegment theorem states that the midsegment of a triangle is two things. One of those things is half as long as the third side. So you've got three sides to a triangle, two sides that the midsegment is actually splitting in half, and then that third side's twice as long as the midsegment. And the other thing is, this is going to be parallel to the third side, so half as long and parallel to the third side. Now note that there's three midsegments in any triangle. And why do we care about midsegments? Well, just ask Link. Let's use the midsegment theorem to find some lengths of segments. Given that DF, DE, and EF are midsegments, I mean, we can't assume that if they didn't tell us that, determine all the missing segment lengths and find the side lengths of triangle ABC. All right, so here's the order that I found things in. I'm just writing this up here so I know what to expect when I click the button here. So one thing that we can use to help us out is that a midsegment divides sides into two congruent halves. So for example, BD has to be the same length as AD, which means BD is also 6. And that means that if I add those together, I find triangle length AB, which is going to be 12. Now we also know that midsegments are half of the third side. So that means that segment EF is going to be half of AB, which is the side that's across from it. So that means it's going to be half of 12, or 6. And then we also know that the third side is twice the midsegment. So that means that AC over here is going to be twice as long as its midsegment third side here, DE. So AC is going to be 10. And then we can find all the other sides. Pause the video and see if you can figure out all the other missing sides and segments. All right, next I'm going to find AF, that's half of 10, which is 5. FC is also 5 then. And BC is the third side for midsegment DF. So BC is going to be twice as long as DF, so 14. And then BE is half of that, 7. And EC is also 7. Let's do a real-life application. Triangles are used for strength in roof trusses like this one. In the diagram here, they're telling us UV and VW are midsegments of triangle RST. So given that, find the length of UV and side RS. Let's start with UV. Actually, pause the video and see if you can do this on your own. Okay, let's find UV. Since it's a midsegment, that means it's half of third side RT. And since RT is 90, that means UV is going to be half of that, 45. And that's inches. Let's find RS now. Since VW is a midsegment, that means RS is going to be twice whatever VW is. So that's going to be twice 57, which gives us 114 inches. We're going to revisit a triangle that we found all the segments for earlier on in this lesson. This time we want to find all the missing angle measures. And the original angle measures are given in purple here. So we've got 45, 77 degrees, and 58 degrees. Now we know that since all the triangles are similar, all the corresponding angles are going to be congruent. But how do we figure out which angle is which? Well, the angles that are congruent are going to be across from the sides that are congruent. So for example, all the angles across from or opposite from the 5-inch sides are all 58 degrees like this one. So that means that, for example, there's 58 degrees here, 58 degrees over here, and 58 degrees down here. All the sides that are across from the 6 inches are going to be 45 degree angles. So we've got 45 here, 45 over here, and 45 down here, angle C. And then finally, all the sides that are across from 7 inches rather, are going to be 77 degrees. So we've got over here 77, 77 up here, and 77 degrees over here. We're going to do one more problem with midsegments. This one we're going to bump it up a little and do some algebra. So we've got this triangle GHJ where A, B, and C are midpoints. If AC is 5x minus 2 and HJ has a length of 8x plus 10, what is the length of JB? Pause the video and see if you can puzzle this one out. All right, so a good way to do this would be to set up an equation with these two expressions. But before we do that, let's define the relationship between the two segments that they represent. Since AC is a midsegment, it connects midpoints, that means that HJ is going to be twice whatever AC is. So using some algebra now, we can say 8x plus 10 equals 2 times 5x minus 2, the expression for AC. And then let's distribute that out. So that'll be 10x minus 4. Subtracting 10 over here, and then subtracting 10x over to the left side, we should have negative 2x equals negative 14. Or if we did it the other way, we'd have 2x equals positive 14, one way or another. So that's going to be 7 for x. And then what do we have to plug this into to find JB? Well, there's no direct expression for JB. You could plug 7 into HJ over here and take half of that. Or, since we know AC is already half of JB, we can just use the AC expression. So just plug 7 into the x right here, 5 times 7 minus 2. 35 minus 2 gives us 33. Well, that's all we have for midsegments. Until next time, this is Mr. Sutton signing off.